In these practice problems, we're going to talk about cash flow diagrams and equivalence. A cash flow diagram is a visual representation of how your project cash flows or investment cash flows are depicted. And every cash flow diagram has a particular point of view. If I am an investor that is going to try to earn money and take it out in 5 years, I may have a bunch of downward arrows that represent what I'm investing. And then when I want to get my big return, my up arrow is there. So that's sort of an investment type of a scheme represented by a cash flow diagram. If I'm talking about taking out a loan, so if you have a student loan that you have taken out with the government and you are receiving it now, and then once you graduate next year you begin to pay it, that would be represented a little bit differently. So you are receiving some money right now, that is your loan, and then next year and maybe for the next 10 years you're going to pay these back in a certain installment. So that is a cash flow depiction, and each of these arrows should have a cash value on it, and maybe these are all the same, and maybe your loan is for $10,000 and you would have the number of years represented written on your cash flow diagram. So in the problem that we have for this set of practice problems from chapter 3, it says, what is the future value 10 years from now if you invested a lump sum of $5,000 today, $6,000 in 2 years, and $8,000 in 5 years? Assume an interest rate of 10%. Draw the cash flow diagram. So I'll try to draw a little cash flow diagram here. And I have a lump sum of investing $5,000 today. Year 1, year 2, I'm also investing a little bit more than that, so my arrow is a little bit longer. 6,000. Year 1, 2, 3, 4. Year 5, I have 8,000. And then year 6, 7, 8, 9, and 10. And in 10 years, I want to find out what my big payout is. Okay, so this brings up the topic of economic equivalence. And the book defines economic equivalence as the process of comparing two different cash flow amounts at different points in time. And it exists between cash flows that have the same economic effect and could therefore be traded for one another in the financial market. So in other words, what future value at year 10 represents the sum of what these are equivalent to if we added them all together? So because of the time value of money, I cannot simply add up $5,000, $6,000, and $8,000 to find out what the value is in year 10. I have to first convert each of these to the same time frame and then add them up. So because I'm looking for what the time frame is in year 10, I'll bring each of these values to their equivalent value in year 10 and then add them up. So if we wanted to say what is the future value of $5,000 in year 10, that's going to be 5,000 multiplied by 1 plus the interest rate, which is 10%. And we're looking at that in year 10. Okay, and that's going to add up to a certain value. The future value of the $6,000 in year 10 is going to be $6,000 multiplied by 1 plus 0.1, and that's going to be to the 1, 2, 3, 4, 5, 6, 7, 8 years. And lastly, we have what is the future value of the $8,000 in year 10? So 8,000, 1 plus 0.10, and that of course is moving out 5 years. So I could write these all out separately, but what you'll get used to doing is you'll begin to say, okay, well, because we're talking about converting these all to the same time frame, The future value in year 10 of this whole series is equivalent to 5,000 multiplied by 1.1 to the 10 plus 6,000 multiplied by 1.1 to the 8 and 8,000 multiplied by 1.1 to the 5. And do all the math and add those up. So I'll pause the video and find out what that calculation is equivalent to. So my math finds that this is equivalent to 12,968.71 plus 12,884.08 plus 12,861.53. Now that's a pretty good investment to earn 10%. Not likely to happen on our markets these days. $38,714. So what does this represent? This is saying that in year 10, $38,000 is equivalent to 5,000 10 years before, 6,000 8 years before, and 8,000 5 years before. So these cash flows now, year 2 and year 5, are equivalent to a future value in year 10 of 38.7 thousand. Okay, let's try a second problem. The question is, what is the present value today of a lump sum of 5,000 invested in 2 years, 6,000 in 4 years, and 8,000 in 5 years? Assume an interest rate of 10% and draw the cash flow diagram. So if I was to draw the cash flow diagram for this, we have a question that says, what is the present value? So right away, I know that I'm looking for this, a present value. And that's saying that in year 2, I'm investing, so I'll put my number up there, I'm investing 5 grand. In year 4, I'm investing 6 grand. And in year 5, I'm investing 8 grand. That's a 6. Okay, so based on what we know from the previous example, we know that we can, if we want to find out what the equivalent value is for these 3 investments over those different time frames, we need to bring them all back to the same time period, year 0, for present value, and then add them up. So I'll do that by looking at the present value in year 0, and I know my formula for finding a present value when I have a future value is this. So I'm going to say $5,000 divided by 1 plus 0.1, and is 2 in that case, plus $6,000 in year 4 and $8,000 in year 5. And if I'm to do the math on that, it results in an answer of 4,132 plus 4,098.81 plus 4,967.37. Oops, I lost a number there. 67, which becomes a total of 13,197 and change. So the equivalent value of these three disbursements of money over those three different time periods is 13,197.